Hi guys, this is 2023 AMC problem 7, and we're looking at this coordinate algebra problem here. So it says a rectangle with sides parallel to the x-axis and y-axis has opposite vertices located at 15,3 and 16,5. A line is drawn through the points 0, 0 and 3, 1, and another line is drawn through the points 0, 10 and 2, 9. How many points on the rectangle lie on at least one of the two lines? So I've already drawn in these lines here, but they aren't very exact, so I'm not sure if they actually land in the points that I've drawn them in. But what we can do is when we have these little diagrams, it can be really helpful to draw lines like this to see like generally where they land. So if I like suspect that, oh, this line might cross the corner here, that would be a lot easier for us if it did, since then it would only hit in one spot here, right? So let's first write out the line equations for both of these lines, since we just want to find out where they go and where like what points they hit in this general area here, right? So let's start with the line AB, and we can pretty easily find the slope here, right? Because we have our 2 points here, and we know that slope is y1 minus y2 over x1 minus x2. So in this case, that's 1 minus 0 or 0 minus 1, but I just did 1 minus 0 since it's positive, and then 3 minus 0, 3 minus 0. So our slope should be 1/3. Now that we have that, we also know that the y-intercept is 0, right? So which makes this line just y equals 1/3 x, since our b is 0. So now we know this. Um, we can see that this point, 15,5, would be on that line, since that fits the if y is 5, sorry, and x is 15, then that works, right? This equation works. So we know it passes through this point here. And that means it doesn't pass through any other points on this rectangle here, since it hits at this bottom corner here and continues to decrease, and there are no further points that are lower than this point here, right? If that makes any sense. So we know where, oh, sorry, I chose the wrong spot here, right here. So we know where this line AB hits. Now let's look at CD. So let's get rid of all of this. Let's find the line equation for CD. CD, CD starts here and goes down here, and it has, we can also find the slope here pretty easily. So again, slope is y1 minus y2 over x1 minus x2. So let's do 10 minus 9 over 0 minus 2, which is 1 and negative 2. So it's negative 1/2 is the slope here. So now we can find the equation, and we know that the y-intercept here is 10. So it's y equals negative 1/2 x plus 10. So now that we have this, we can, because before we thought that this point here was on the line CD, and let's test it out. Let's see if we plug in 15 as x and 3 as y, this equation will be equal. So this will be 3 equals negative 1/2. Negative 1/2, what was it? 15 plus 10. So we can see pretty quickly that this doesn't work here. I mean, this is a quick trick, since we know that 15 divided by 2 wouldn't be an integer, right? It wouldn't be an integer, so it wouldn't allow this equation here to be an integer. But if you want clear proof, we know that 15 over 2 is negative 7.5 plus 10. So this side is 3 and this side is 2.5, which is not equal. So then we know that this doesn't actually go through this point, but let's see where it actually hits on the 15 line instead. So plugging in 15, we know that this equation is equal to 2.5, which is below this point here. So it's not it doesn't hit at 3, it hits at 2.5, which is below this bottom corner. So we know that it never touches any point on this rectangle, right? So the only point that it actually touches um through AB is this point up here, 15 5 15 5. So we know that there's only one point on this rectangle that lies on at least one of the lines. So our answer should be B. Let's check that. Yep, answer is B. All right, thanks guys.